Hello, my name is Marius and I'm going to present you the open source journey of the Delta Lake Connector, which was internally present only for Starburst, but after some negotiations, we've decided to open source it, and this has led to an immensely good decision because it received a lot of positive improvements. I'm a software engineer, and I had a stint of doing data engineering, and I was working with Snowflake and dbt, and I kept on wondering how do they process these large amounts of data, and by chance I stumbled upon Trino, and this has opened to some extent my eyes on how this may happen. And since then, I've done a lot of contributions to the open source project, and subsequently, I started working with Starburst, and in the past 2 or 3 years, I've been very much concentrated on the data lake connectors, specifically Delta Lake, Iceberg, and Hive, with a short stint also on Hoodie. I'm going to present you very, very shortly what the Delta Lake table format is. Delta Lake table format is pretty opinionated. They use Parquet as a data for the data file formats, and they have a bunch of other metadata files that they can use to prune files that are not needed for a query, or they can use also this metadata for ensuring that operations are done in an ACID fashion. The metadata structure looks the Delta Lake table format looks similar to what we see here in this slide. We have a Hive-like structure for the partitions. The files are found under partition directory. The data files are found under partition directories, and the changes which are done on the table are monotonically ascending, are structured in log files which are monotonically ascending. You can see 1, 2, 3, 4, 5. And in order to improve the reads, we also have checkpoints for the so-called checkpoint files, which summarize all the changes which have been done to the table until that point. Now, open sourcing Trino Delta Lake Connector has in the end of 2021, Databricks decided to create a PR on the Trino open source project, which was containing a version of the Trino Delta Lake Connector, and this has motivated Starburst to actually respond by open sourcing their own version of the connector. And for a short stint of time, we were having 2 competing PRs. And this obviously has led to the parties joining together and sitting at a table, and they decided to finally agree on going forward in the community with the Starburst version of the connector. And subsequently, Databricks was quite supportive, and they offered to the Trino Software Foundation also cloud resources for testing the connector. Now, after the connector has been open sourced, in the beginnings its open source journey, we've started to see small contributions to it, starting with support for DDL commands, like adding a column or doing comments on the table. Or then there was one limitation that Delta Lake table format had was that you could not add initially, you could not rename a column or you could not drop a column, and which they addressed in a subsequent version of in the Delta Lake table format, and we've added also support for this feature, being able to do schema evolution scenario, to read tables which are ready for schema evolution scenarios. And we actually noticed a high increase of interest. So people reporting bugs and feature requests on the connector. Now, subsequently, what happened was that a very, very long request on Trino got materialized. This was the merge statement support. And when this happened, DBT Trino also adopted it very, very swiftly. Actually, quite a few days or a week after it happened. And both of Trino and DBT Trino started to get a high increase in interest and high increase in usage. The second half of its first year on the open source showcased also this increase in interest. People who were using DBT Trino were somehow motivated to be able to rename temporary tables, and this has led to the addition of the support for alter table to be renamed. We've added very, very many Parquet improvements, and at Starburst, Raunak Moraka is is the go-to person for getting Parquet knowledge. And quite a few things started to happen. People added the ability to register a table which existed on the storage, or they added support for Trino views. By chance, we stumbled upon a situation where for test purposes, we were removing Delta Lake table, and we noticed that it contained a so-called directory object in S3, and this was not getting deleted, and we didn't know why, and then we investigated it quite in detail, and we were thinking to implement a corresponding algorithm for it, and we went through several versions of it, and fortunately, we had massive help from James Petty, who works with Amazon, and we did together an efficient algorithm to batch the deletions of a specific directory in S3, or a prefix, so to say. And when we were doing this, we got the first hints that from David Phillips that he is planning to, so to say, to do a de-Hadoop of Trino. And Trino, in the meantime, Trino is one of the first mature engines who's working without reliance, direct reliance on the Hadoop library. Now what the 2023 has had also support for writing in tables which have check constraints. Check constraints are the ability to discard the query, actually to fail a query which is trying to insert a statement that contains, that would modify the table in such a way that it doesn't respect anymore the check constraints. So for example, if the age is supposed to be over 18, then if a row inserted is containing this value under 18, then the query will fail. And Delta Lake being driven or being dedicated initially for Spark engine contained check constraints in Spark SQL. So we had to define a grammar of our own to be able to actually limit the amount of check queries which we can handle. We implemented also push down for reading of nested columns. So in order to reduce the amount of data being read from Parquet files, we have added write support for tables which do schema evolution. We've even had it's not it's the Delta Lake Connector has received change data feed support, which allows us to backtrack how the table got to its current state, which has an immediate use case of doing CDC use cases from the source table to other downstream tables. Merge on read was also one of the additions in one of more recent Delta Lake table versions. And Trino Delta Lake Connector has received support for it. And in the end of 2023, we were feature-wise, for the most use cases that Delta Lake table supports, we were on parity with Spark. Now, some of our Jonas, who is also in the room and who also presented the Dune improvements done on Delta Lake, were complaining that the amount of data read from the checkpoint files was too big, which was leading to query planning being relatively slow. So people started to complain and to actually to figure out what better ways are to read the checkpoint files. And one customers of ours was having even checkpoint files which were depassing 1 gigabyte in size for huge tables of theirs. And this they were complaining that the query planning was taking much too long. And this has led to quite a multidisciplinary effort to actually figure this one out. And we've added quite dramatic improvements by pruning very, very much the amount of data being read from Parquet. And we did this with the help of our colleagues, Piotr Findeisen and Braunak, who actually, we collaborated very much to figure what we can do. And the results were very, very impressive, in my opinion. Now, after we've done most of these things, the Trino Delta Lake Connector was and is a very, very strong connector in terms of features, in terms of stability. And people were not using it only as a side thing that to spare costs of not running on Databricks, but actually they started to use it for write scenarios, and they started complaining, hey, I have situations where I want to write concurrently in these join partitions which don't affect one another, And we want to support such use cases. And we've addressed this specific use case. We've added support for reading from V2 checkpoint files. The Delta Lake table format is extremely aggressive in terms of features. Then they do a release every 3, 4, 5 months. So it's very, very it's very important to try to keep up. One very interesting addition, which I'll be speaking in the following slides, is create or replace statement support. And another very relevant addition for this connector was the time travel support. Now, I won't be diving very much into local file system caching of metadata and data files because this has been done already by Jonas. They have been driving this feature development very much. And Raunak Moraka, our Parquet expert, was saying that this is something that he planned to do for a lot of years, and he was very, very happy to help. And the results, as Jonas explained, are quite impressive. Databricks has also showed interest in collaborating with Trino, and they added support for getting in communicating with the Unity Metastore. They added an extension in our Hive Metastore client for being able to communicate with a Thrift Metastore in this specific situation, the Databricks Unity Metastore. And with regards to create or replace, as I was saying, this has been quite a long effort. It has been started I think in 2022, and it took some time to accept first the syntax, then to accept how the statement, how the inner workings in the engine will look like. And the main use case of it was the ability to have a dashboard. We have in dashboards, they sometimes rely on tables which get updated every day, and they get fully refreshed. And in order to refresh them, we simply have to delete the old table and to write a new version of the table instead. And with the help of one side effect of this was that for a very short stint of time, the dashboard was saying table does not exist when it happened to refresh at the time when the table was dropped. And create or replace solves this specific problem. And again, the colleagues from Dune were very, very interested on this feature, and they added support for it, and they even improved also the inner workings of it, and we were very, very happy to work with them. Time travel is something that in my tenure since I've been working with the Delta Lake Connector has been a highly, highly requested feature. People were asking, I think even 3 years ago, when will we have time travel? And a contributor from the Trino community was, so generally when something does not exist, people get inventive. And one of the contributors was slick enough to notice that he may create a shallow clone of the table through Spark and read it through, which was corresponding to an old version of the table, and read it through Trino. And when the source code of the Trino Delta Lake Connector was in a good shape, as I was saying, in 2024, we got to a very good shape with the connector, both feature-wise and also code-wise. we've added also Trino, the time travel functionality. Now, Delta Lake Connector would not have got to this state without the influence of a few individuals, which I'm going to name by specifically. Alex Joy is the first engineer who worked on he wrote the initial version of the connector, and being very, very acquainted with the inner workings of the Delta Lake table format, he has reviewed and shaped the most important functionality added on the connector. Piotr Findeisen is probably the glue which has kept more or less the consistency and the quality in terms of the connector. He very likely shaped most of the outstanding improvements by participating in countless reviews and doing the code quality, which is a constant in the Trino open source project. Therefore, you probably know him as Findepi from GitHub, and he's an open source champion in my eyes. Yuya Ebihara is a colleague of mine who, in my eyes, he has done really an explosive amount of proactive contributions, and probably his contributions led to Trino Delta Lake not being a decent alternative, but being actually a competitor for Spark engine in terms of dealing with Delta Lake workloads. And there were countless individuals from the Trino open source community who told that they trust very much Trino to work on their critical Delta Lake workloads. And Yuya Ebihara, you probably know him as Ebi Hr. GitHub account. He's also very, very present, and you very likely know him either from the community or from PRs, and he's an open source champion as well. Now, the Trino, a very important role in getting the connector to where it is the fact that we relied very much on the open source community. There's a lot of actionable feedback which has been provided by the community. There's a lot of informal and discussions which happen on Trino Slack or which happen on the GitHub channels, and very passionate engineers give us feedback and show us, hey, this is not working, how can we help? And this makes working on the Trino open source project quite a pleasure activity. Now, with regards to the next features, which I'm aware that will be coming, we are planning to add deletion vector support on the right, so to be able to write deletion vectors. Just to deletion vectors are the feature which allows merge on read for Delta Lake connector. Then we are trying to store metadata. The table metadata on the metastore in order to improve, to accelerate queries which are relevant for BI tools, so that they can, they rely solely on the metastore and not anymore on the storage, on the object storage. We are likely going to have a better integration with the Unity catalog, which has been recently open sourced, and we are planning very likely to be able to read tables having liquid clustering. Thank you very much for your attention. I'm free for any questions.
Before we start with the question, I want to mention that in his usual humbleness, he didn't mention that he's also one of the wizards of the Delta Lake Connector on his list. So thank you so much for your work, Marius. I'm sure we have questions considering all the experts that are here. So there's one over there. Also maybe online call. What's going on?
So you talked about future work of storing table metadata in a metastore as well. How do you think about keeping that in sync with the metadata stored in Delta Lake files itself?
Can you please repeat the question?
So one of the last things you said was storing table metadata in a catalog, for example, for BI tools to do quicker lookups.
Yes.
So how do you think about like keeping the metadata in sync between a catalog and the Delta metadata files themselves?
This is part of the OpenPR. Whenever there's a write done or a change in the table structure, we have an optimistic strategy of keeping things in sync by updating the table schema. Does this answer the question?
Yeah, I guess, do you have any mechanisms for what if they fall out of sync? How do you recover which one is treated as the source of truth? For example, in a partial write scenario?
If you remember in the initial slides, the transaction log files in the Delta Lake table format have a monotonically ascending versioning number. So if the current table version doesn't correspond to the version stored in the metastore, then we will obviously go on reading from the storage the metadata and figuring out what the table schema or the table comments are.
Okay, thank you.